experimental setup name is inherent and installed characteristics of control valve. Control valve is a very important process control element. The temperature process, level process and flow process and pressure process. In all these processes, this control valve is used as a final control element. This is used to control the flow rate of input liquid or outflow liquid. So liquid input or materials input, whatever it is given to the process tank is controlled. The flow rate of the liquid is controlled. Either it could be inlet liquid or it could be the outlet liquid. The flow rate of the liquid is controlled using this control valve. So this is a very important process control element. So the experimental setup consists of 3 control valves: equal percentage valve, quick opening valve and linear valve. The layout of the control valve characteristics is shown here. This experimental setup consists of one tank for the water supply. The water from the tank is pumped and it is taken into the overhead tank. From the overhead tank, the water is passed through the pipeline, through the rotometer, and it is connected to all the control valves. So when we are doing the experiment of equal percentage valve, this valve alone is opened and other 2 valves are closed. So there are 2 types of characteristics in the control valve. Based on the relation between stem position and the flow rate, there are 2 types of characteristics in the control valve. One is inherent characteristics and another one is installed characteristics. Inherent characteristics shows the characteristics of control valve, which is entirely related to stem position and the flow rate. The flow rate of the liquid passing through the control valve is based on the control valve characteristics alone. Such a type of characteristics is called as inherent characteristics. The installed characteristics shows a different flow rate based on the pipeline connection. Since the control valve is installed in the pipeline, the pressure difference will influence the characteristics of the control valve. So the flow rate will be different comparing to the inherent characteristics. So inherent characteristics is based on design of the control valve and the flow rate is entirely dependent upon the control valve alone. The installed characteristics is dependent upon the pressure difference in the pipeline. So first we shall see about the inherent characteristics of the control valve. So these are the 3 types of control valve based on the characteristics of the control valve. One is equal percentage and another one is quick opening and third one is linear valve. The equal percentage valve exhibits its characteristics for the stem position and the flow rate. For 1% of stem position, the 1% of flow rate will be raised in the flow stream through the control valve. Whereas in the quick opening valve, for small changes happening in the stem position, the flow rate will be increasing immediately. In the linear valve, the stem position and the flow rate is linear. So these are the basic idea about the 3 control valves used in the experimental setup. So first one is linear equal percentage control valve, second one is quick opening control valve, and third one is equal percentage linear control valve. So this equal percentage control valve has add to close type. That is, the signal is applied at the top of the control valve, so that once the signal is passing through this pipeline, the control valve stem will be moving down, and then the flow rate will be reduced when we apply the pressure, because it is add to close type. There are 2 types of signal given to the control valve. One is add to close and another one is add to open. The add to close type is designed here. So when we apply the pneumatic signal here, the control valve stem will be moving down and the flow rate will be reduced. So the flow rate will be reduced here and it is observed here. And in the quick opening valve, for the small changes happening in the stem position, the flow rate will be very high. It is immediately opening. The flow rate will be increasing suddenly in the quick opening control valve. Whereas in the linear valve, for the changes happening in the stem position, the variation will be linearly. That is, for 1% of stem position, 1% of flow rate will be varied. That is the basic idea about the 3 valves in the experimental setup. So 2 types of signals we give. One is air to close and another one is air to open. For the equal percentage valve, we apply air to close, and for quick opening valve and linear valve we apply air to close, that is applied underneath of this control valve. So first let us see about the inherent characteristics. So first part is, in this experiment, first part is to obtain the inherent characteristics of the control valve. The inherent characteristics is said to be that the flow rate is dependent upon the control valve. So actually the control valve setup has the control valve connected in the pipeline, but we have to close this pressure coming across this control valve. So this is closed here. So this is considered as the control valve exhibits its characteristics purely based on the control valve alone, and this pressure across this pipeline will not affect this control valve characteristics. So the setup is arranged for inherent characteristics. First we have to note down the position of the stem. Here the scale is given. For each division is 1 millimeter. Each division in the stem is noted as 1 millimeter. So for the movement of this stem position, what is the flow rate of the so there is no flow rate. So here it's at the initial position. The stem position is at the initial position and the flow is less, and you can see that it's almost at the end point. So the flow rate is not available here because we apply the pneumatic signal here. It is regulated and we apply the pneumatic signal here. Since it is air to close, when you apply the pneumatic signal, the control valve stem position will be at the down position. So it will not allow the liquid to pass through the pipeline. Now if we make the stem position to move upward, that is by releasing the signal, pneumatic signal, the stem position moves upward. The stem position moves upward, correspondingly the flow rate will be moving upward. So the students has to take the readings for 1 millimeter of stem position. For 1 millimeter movement of stem position, what is the flow rate, that is calculated. At the same time, here we have the pressure delta P, which is pressure across the control valve, as a constant 1. So for inherent characteristics, this pressure will be kept constant and the flow rate is taken down here, and the stem position is noted here. So the inherent characteristics is plotted. The table for the inherent characteristics is plotted between stem position and the flow rate for the constant pressure. That is the inherent characteristics. So the student has to mark the graph between stem position and the flow rate. That is the inherent characteristics of the equal percentage control valve. Similarly, if we apply the pressure to the quick opening valve, For the small changes happening in the stem position, the flow rate will be immediately moving. That we can see in the so the pneumatic signal is connected here. It should be reduced before connecting to the control valve. So it is connected and it is tightened. This control valve is closed. Other control valves should be closed. This should be open. This control valve should be open. Now the quick opening setup is ready for inherent characteristics. So if we apply the pressure, so we are applying, the stem position is at 0 now. Stem position is 0 and there is no flow through the pipeline. So we are going to apply the pressure here. So for small movement of stem position, the flow rate is maximum. For the small changes happening in the stem position, the flow rate is maximum. So student has to mark the stem position and the flow rate quickly, very quickly, because the quick opening valve is very fast in its action. For small changes happening in the stem position, the maximum flow rate is available. So if it is increased beyond, the flow rate will be maintained at the same level. So this quick opening is having fast response. So it is used in the on-off control applications. The equal percentage valve is used in chemical process for mixing two reactants or two liquids in the process tank. Another one is a linear valve. So we can disconnect this and we can turn off this control valve. Quick opening control valve is over. So next experiment is so we should reduce this. So this is connected to linear valve. So for the small, in the linear valve, the stem position is linearly moved and flow rate is also linearly moved. For the linear increment of stem position, we can see the linear flow rate in the flow rate measurement. So in the same way, we have to turn on this linear valve. We have to turn on this linear valve for its operation and apply the pneumatic signal to this. And again here we have a air to open type of control valve. So if we are applying this pneumatic signal to this control valve, the flow rate will be increased.